Yes, sir. We are live now. Please start.
Thank you. All right. Hi, everyone. I'm Gopi from IBM Software Labs in Bangalore. Today, my topic is data science and industry perspective, right? So let me start by sharing my screen and then we can go from there. All right. So, data science, as we all know, is critical to successes of modern businesses. It's essential. We cannot, if there is an enterprise that is looking to modernize their businesses, accelerate growth, data science is inevitable in their practice, right? Now it's the numbers tell for itself, right? There has been an analysis from Gartner that we have about 3 trillion in business value that's going to be accelerated with data science or AI augmentation. Here I'm going to use data science and AI, interchangeably. I know there is always two school of thoughts about one subsuming the other, like data science being a subtopic of AI, or AI is branch of the whole of data science. We don't have to get into the nitty-gritties of that. For this particular lecture, we could assume that the context that we are talking about is data science as a practice where we are helping businesses modernize their businesses with AI augmentation or data science, using data science, right? And the value, the business value is phenomenal and it's very attractive. There's no two ways about it. So, at least in our IBM surveys, we've found that 9 out of 10 enterprises say that without AI, we will not be able to compete in the market in this highly accelerated, competitive business situation, right? And the growth potential is exponential. As you can see, it's double or triple in cases. We have seen, even in some of the toughest times like COVID, we have seen businesses grow due to the intelligence that it could gather on where the most needed demands are for the supplies, right? And we've seen digital growing really deep and wide because there is always AI in the background accelerating and finding out and fueling where these needs arise from, right? Okay, it's the attractiveness is still there for AI as we keep seeing all these messages from Gartner and even IBM surveys. So one thing is AI is actually AI transformation is a journey for any business, right? From startup to companies that are decades old, they uh, while it's attractive, it can be hard for enterprises to adopt AI if it is not done in a guided and guided by experts and in a methodical way, right? You need a methodology uh, to adopt AI. It's not about um, building building AI models alone. While it's core and central, it's you will see that it's a very small piece to the whole journey to AI. That's what people call it. Like you will start with operational efficiencies, um, and then build business intelligence and data marts to do descriptive analysis, and then you will transform to predictive, and then completely transform your business models. So this requires a very methodical, meticulous approach than trying to solve pockets of problems, automation problems, or let's say pattern recognition problems in enterprises with ML models. Um, so let's keep getting deeper into it. So so yeah, I mean, just to reinforce, AI, though attractive, is not a magical black box um, that will uh, that will just on a flip of a button will take businesses from point A to point B. So it is a journey, and it requires uh, methodical approach. Let's look at the methodology, right? Um, so we all AI exercises start with data. So data is the fuel for all AI. Data, otherwise information, needs to be well organized, and there is an architecture involved to organize this information. Um, so we call this information architecture, where you organize your data in such a way that it's consumable by the AI processes to derive value out of it, right? So you need an information architecture. There is no AI without an IA, right? So as the MIT Sloan quote says, no amount of AI algorithmic sophistication will overcome a lack of data architecture, right? And you might have experienced, even in the smallest model that you would have developed or experimenting with, you would spend, like, close to 80% or 60 to 70% at least in trying to organize your data, cleaning your bad values. And there will be challenges like, oh my God, there is some sensitive data. How do I get rid of the sensitive data but still use it for my data science purposes? How do I anonymize the data? How do I ensure that after anonymizing the data, is it going to be useful for my machine learning, or that's going to alter um, my data science effort because I changed the data? So there are various techniques to ensure that you still retain the value of the data when you are preparing the data with privacy in mind, right? So we'll look at challenges as we go along, and the risks that we will have to cater to when we are practicing AI. Again, it's not about uh, applying a deep neural network to a rectangular data or to some images, and predicting even with 99% accuracy uh, is probably a start. It's not good enough for enterprises to consume, right? So IBM has been in this journey in understanding the industry perspective, um, trying to talk to like numerous enterprise clients um, on how their AI journey is, and they've come up with a view, right, a point of view, and we call that the AI ladder. Um, the always as AI starts with data, um, you will have to start collecting all the useful data. And you might know by now that the more data you give to a model, the better it can analyze and predict. Uh, yeah, it might throw away a lot of data that is irrelevant to the pattern that is emerging. But uh, uh, more the data, more accurate the pattern that it is going to emerge with. Um, it's going to take longer, but it will definitely fine grain it. And some of the neural networks that you might have played with uh, clearly could indicate that as you keep adding features, it's going to improve on accuracy. As you keep adding, and you will not know what kind of patterns emerge, because that's for the algorithms looking at the data and optimizing um, on that data is going to come up with. And that's the whole point, right? It's going to learn on whatever data you throw. So more is good, but enterprises have structured and unstructured data lying everywhere in various forms. From images to PDFs to rectangular databases to CSV files and Excel sheets to um, it lies everywhere, and attempts have been made to consolidate and prepare data lakes um, by bringing all that into, say, for example, a Hadoop cluster, or uh, uh, or any other central way of managing data. But again, these attempts might fail if it's not augmented with an assumption that there is always data that is going to be created somewhere in some corner, which is valuable, and it could be a data source that uh, um, that's not a data lake type data source, or HDFS type like data source. Like today we have about 60, 70 different relational databases, or even more popular ones, I'm saying. And um, different lines of businesses inside one enterprise could be using different technologies to process data, and moving all that data and centralizing it in one format or other is impractical. So the alternate to that is to organize and govern. And I mean, okay, let's talk about organize a bit later. Like, at least to collect and understand all these data sources, you need a platform that could plug into any data and pull the data um, to into um in uh, in a platform that data science can be practiced. So what kind of tools that are there to be able to connect to all these different data sources, and have a consistent view, and play with runtimes like big data and small data runtimes, um, uh, connecting to these data sources, and having a consistent view. That's the collect phase. Um, uh, and when it comes to organize, it's all about governing that data that is coming from different data sources. Data scientists are always not having the privilege to see the actual data collected by the businesses. Even if it is collected, it would have undergone privatization, or privacy. It would have undergone a lot of policy transformations before it is made available to data science users, because privacy is critical in this modern world. And you've seen various um, uh, 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 you know, data leakages and privacy aspects emerge. And AI cannot be practiced without keeping privacy in mind or security in mind, right? Um, then comes all the analysis tools, data science analysis tools with all the popular frameworks, like, for example, TensorFlow, or scikit-learn, or any of the plethora of data science tools or machine learning tools, and frameworks and libraries that you can think of, right? To build the model, and apply what is called uh, trust in the model. Like, is the model that you're building trustworthy, right? Did it apply any? I mean, is it? We call it fairness. Does it? Did it develop a bias towards something that it found in the data? And if we deploy it to production, would that bias get carried over um, to to your business that could adversely affect your business? So these things need to be kept in mind when we are building models. It's not about applying an algorithm. Say, for example, I'm taking a trivial example here, applying a linear regression to a rectangular CSV file. Even if you're confident that you have everything in that CSV file, and you build a model out of it, it's still not ready for operationalization until you apply all the controls that uh, that we're going to see in a bit, right? So how are we doing on time? Okay. So in terms of this is an IBM's stack of practicing the AI ladder, the collect, organize, analyze, and infuse AI. That's what you see in the left hand side, and here is a software stack that supports this, but it's much more than that. It's So enterprises are wary of what is called technology lock-in or vendor lock-in. When they need the flexibility to move to newer technologies when they are out. It shouldn't be tied to one I would say format or another, or it should be consistent when you are when you are deploying and maintaining these systems that are continuously ingesting data, training on data, learning new patterns, and recommending throwing recommendations um, at consumers, right? So um, it requires the platform approach and flexibility to be deployed anywhere, and should avoid vendor lock-in. Uh, it's If you see, the architecture is deployable across multiple clouds, including the popular ones that you might have played with, but it's critical that it should be flexible, consistent, and it should cater to all the rungs of the ladder that we discussed. It should be able to support collecting of data from various data sources. You should be able to apply governance access rules across no matter where the data is coming from. If a consumer of data, which is a data scientist, uh, need to own should see only certain aspects of the data that is relevant for the particular use case where the model is getting developed. The governance policies should be applied no matter where the data is traveling and coming to the consumer, across clouds, across on-prem systems and public clouds. So this requires a careful thought about how centrally governance can be applied. I mean, governance can never be underestimated when it comes to enterprise data science practice, right? Um, so let's keep going. So in spite of all, what we have seen is, in spite of all the skills that the customers possess in data science, like there will be experienced data scientists, there will be experienced industry practitioners, legal advisors, and we have the software stack. Okay, let's say from IBM we go with this particular platform. We call it a platform. It's not a simple stack, it's a platform of data science. Now if we do that, it requires expert advice from practitioners um, to help the customers in that journey, to help large enterprises in that journey. So this is what is the difference between the industry practicing AI and what we learn in theory as what AI can provide with these models, machine learning models and deep learning models, predicting mm, things with a lot of accuracy. Uh, it it's much larger than that when it comes to a real industry practicing AI. And like we can think about at least 20 to 25 industries that I can quickly name, but I'm saying that each of these industry pillars will have their own regulations, their own when it comes to you applying data to AI, and a single enterprise would need a broader view of how AI is practiced across the industry, and there might be cross-industry experts that would bring valuable advice to the table, along with the best practices of data and AI, in real life, right? So it's not about just getting the platform, developing models, and deploying it to production. Enterprises require help, and we realize that, and from IBM we have a set of industry practitioners feeding into or supporting a team along with elite data scientists called IBM Expert Labs. I'll share more information about that, and you can also talk to them and hook on to the community that the expert labs answer questions from an industry perspective of how data science is practiced, and what needs to be done when you're starting an AI journey in a company that you've been asked to lead. Let's say lead a team of data scientists, developing and modernizing a particular line of business, or even if it is a simple use case, you will see that you will have to undergo the entire AI journey, from collect to govern to analyze to infuse. I don't know how many of you've heard about the AI risks that are. This is not the kind of AI risk where we are talking about job losses and things like that. But what we are talking about is, like, if you apply AI to your business, it can hurt the business if you're not careful enough to pay attention to these aspects of bias that the model could develop without if we are not careful enough, we could we could infuse a bias through the model, that is say predicting something in a specific line of business. um, or uh, or is there a way to explain why the model behaves the way it behaves, and is it okay, right? The third thing is like, is it um, is it okay for if in the future the condition changes, is it okay um, for the model to continue to predict the same way it was predicting in the past, right? So these are inherent risks when you adopt AI, and we should have very good control over these aspects of a model. Otherwise, we might be setting ourselves for failure in terms of adopting AI successfully in businesses. So here are some examples where in the first case, there is a gender bias that model has developed. But how do we find if there was a gender bias? Are there techniques to find the gender bias in the model? Uh, so there are techniques, there are ways to find, by infusing, um, by actually doing a what if analysis, by changing the gender, and see if the model behaves differently. um, so that's a very high level view of things, but there are libraries and frameworks around it as to how you can catch bias that we don't like, even though the pattern says that we probably don't want our businesses to be biased towards gender in terms of our ethical business practice. We don't want to do that, right? Probably the pattern emerges like that, but is that the right ethical way to conduct business because the model says so? So some of these things can be caught through you know uh, mathematical techniques in AI practices. Like, we have, uh, every other vendor has technologies around this. Even there is an open source library called Fairness 360 around this. The That IBM heavily contributes to. So there is explainability of the second case, where the classic explainability is, well, if one customer gets a loan and the other customer doesn't, even though um, the the model said that this customer is not eligible, even though they come from the same locality and most of their parameters are the same. How do we explain to the customer that this is this is because the model gave me this, I'm going to tell you that I can't give you a loan. You should be able to explain why the model behaved that way for that customer, and get get control over that behavior, and things like that, right? And accuracy, again, it's a how much of accuracy is okay, and can we tolerate a drift, and when can we reassess the whole situation by retraining the whole model. All these things should be automated, continuous, and embedded in the process of your AI deployments, production deployments, right? And it should be caught as we drift away from the prediction values if it's not serving the purpose, right? So each of the collect, organize, analyze, and infuse methodologies has its own, journey to complete, right? And you can drill down deeper into this, but we don't have time there to drill deeper into this, right? But let's uh, let's look at the stages of the journey. It's much like our agile methodologies, or our waterfall methodologies before the agile methodology. We should have a planned approach, not a tactical one, but a strategic one uh, that would take each of our journeys of collect, organize, analyze, and infuse. Um, how to plan it, how to make sure that it is tested out properly, drive adoption across the enterprise, so that you are lean and mean when it comes to when an experiment becomes a product. Its form factor completely changes. You're looking for efficiency and performance, and time to market, cost versus profit, and things like that comes into picture. And finally, if we have to scale the model to serve millions of users, what is your deployment characteristics of such a model running at scale, right? How would you deploy it? Would you deploy it in a Kubernetes cluster that can handle millions of requests, or would you just host it in your own standalone server? So there is quite a bit of thought that we need to put in these journeys. And we should also look at, are there existing open source technologies that can help in all of these stages? And is there a platform that can help you with automating some of the requirements in all of these stages? And look actively for experts that can advise you on the tools and techniques that can be used, right? So maybe another 5 minutes. I just want to highlight a few things, like uh, when it comes to trusted AI practice, you will be always challenged with first work. The data is always going to be arriving in a transformed way, and it will be anonymized, and all the privacy rules applied. And you will have to see how you can still keep the value of that data, right? There is a technique called k-anonymity. Here is a list of techniques which you might encounter, or you will be you will be thinking about practicing these techniques, because you are not going to get direct production customer data just served to you in a platter, because because it is sensitive. There is private information. There is privacy laws and that is governing this, and you will simply not get that data, right? So there are still ways where you can apply some transformations to that data, like homomorphic encryption, or we use a technique called federated machine learning, where uh, models get developed, which is, think of it as an aggregated intelligence that get developed at the edge devices, where these data is collected with no human intervention, and then you use that aggregated intelligence into developing a model uh, that can actually combine all that aggregated intelligence at the edge devices. Um, so there are services, APIs, and infrastructure requirements to serve um, such a you know distributed kind of machine learning practice. But yeah, it's good to be aware about these things, where you can see which of these techniques could be used to overcome your data problem, where you're not going to get clear data. Which of these techniques can be used to solve your data science problem, right? This is just to name a few. There are many such um, data transformations that you can apply and still be able to derive value out of that transformed data, um, uh, and get some um, models trained, or even a simple descriptive analytics done on that model, right? On that data. So what are the other things, like when it comes to what kind of skills that you will be expected to have when you start your data science practice, is that in the industry, as opposed to the theoretical or academic world, is that the basic understanding of this fact that AI is a journey for any enterprise. It's not. It doesn't end when you developed a model with 99% accuracy. Um, it is a journey that involves a lot of nuts and bolts around collecting data, organizing data, uh, building a model or analyzing, and operationalizing that model, right? With fairness, with explainability, and accuracy, right? Um, yeah, there are these modern slew of tools that make data science a lot easier, called Auto AI. But you should still, if your basic uh, academic background is not data science, you should still be familiar with optimization techniques, like backward propagation or gradient descent. How does it work? And have a good theoretical background before practicing data science. I mean, I've seen that many people start with a Python library and um, keep going uh, with the frameworks and tools, without understanding how that particular algorithm optimizes the pattern, right? Um, mm, so if we don't understand that, we will not be able to tune the model. We will not be able to pick an alternative to the model, to an underperforming model, and get to the end goal of deploying a model successfully. So it's very important that we get our basics right in all the math that is involved in machine learning and deep learning. Uh, and I don't have to tell about that to academicians like you, but still, I would say, um, please keep an eye on that, and try and be curious about how each optimization technique works, the math behind it. And then be aware of always the model is going to be a continuous learning loop. It should be set up for a continuous learning loop. When new data comes in, it should consider that data. When the drift happens, you need to think about how you can set it up for adding a new feature or considering a new feature to be fed into the model. There are tools and automations. When you think of large platforms like Cloud Pak for Data for example, in IBM, or Watson OpenScale or Watson Machine Learning, you will, which is part of Cloud Pak for Data, you will see that these are all available already in the platform, but still you need to you need to keep that in mind when you are developing and deploying models. So this is a matrix that IBM data expert labs team practice when it comes to helping an enterprise client in their data science journey. I just threw it in to show that it starts with a use case, and it's no different from the regular software development methodologies like Agile, and leverages a lot of open source, and it still requires deep skills to be able to get there. And it's a constant effort to build deep skills in data science, to keep optimizing and stay ahead of the curve, both from the infrastructure that supports your model, like GPUs and TPUs and whatnot. You will still you can't still only think about, or you can't confine yourself to only um, about the algorithms, the optimization algorithms alone. You will still require um, a, a deeper understanding of all the infrastructure that could allow you to set up your model at scale, both for training and deployment, right? These are some useful links where you can go to right away and explore uh, concepts, techniques, technologies, and I would say interact with other developers worldwide, um, on secure data science practice. And you can always seek advice uh, here, right? So there are some open source libraries also. The very good open source frameworks that you will get from here, and what other open source data science practitioners that are consuming these open source libraries are talking about these libraries and so on. So there's a lot of valuable information that you can get and play with the links that is provided here. So that is all I had. So um, over over to you. In terms of question and answers, um, I had an interesting. Let me see if I can pull up the question. I'm going to stop sharing for a second. Okay. Why is it so difficult to run an an evolving model, continuous model on production? Yeah. Okay. So it's uh, it's difficult because the the continuously the environment around it is changing, right? For example, COVID is a classic example. Like, all your models would have gone berserk with the data and influx and predictions that it might be throwing during the initial periods of COVID, unless it was corrected for COVID, because the environment changed. And it can be a gazillion set of parameters that humans probably can't easily predict when it comes to feature engineering, that uh, unless you set it up for automation to include um, these aspects to be picked up automatically through some automation. It's going to be hard, even if you have a very large team. So it's not a hard problem if you are aware of the fact and you are able to instrument it using uh, some well-known automation. And uh, that's that's super critical, because model drift is natural, right? Why, yeah, you think of your own understanding of the world that keeps changing from your childhood to now, and it's no different from for a model. As it learns and the world is changing around it, the model has to change around the world as well. Yeah. So what are some, just finding it hard to read, let me see. Probably okay, Okay, I didn't get the question. What are some data nice? Okay, let me come back to that question. Probably it needs some um, uh, editing or correction. I am trying to understand the question here. Okay, so is auto AI or auto ML going to automate data science? It's an augmented technology. If you look at it, all these auto AI and auto ML tools will say, I've seen some where it says like I'm using this hyperparameter change, like I'm changing the learning rate, or I'm changing the regularization factor, or it it or I'm using this algorithm with 5 learning rates, and um, I got different results for these 5 different learning rates. Sometimes the 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 learning rate is critical for converging properly. So what does it do? It is basically um, methodically taking or changing your features and hyperparameters and algorithms that you would manually do. Like you would probably try 10 different combinations, but auto AI and auto ML can do 1,000 at a time. As far as you have the hardware to support it, it just saves you time in terms of trying different combinations. You will still have to look at the hyperparameters, the features that has been considered, the algorithms that has been considered, and would that would that satisfy your current need, and would that result in a drift? And so there is still data science knowledge and understanding that is required for using auto AI or auto ML. It is just automating the manually cumbersome, iterative things that you're doing as a data scientist. So I wouldn't say it would replace data science. I mean data scientists, right? Um, uh, it would accelerate your data scientists your goal to develop the model faster. That's all. How, as a student, just beginning the journey, start off, how to get the feel of working of these algorithms? I okay. The I, my my 2 cents to anybody who is asking this question is always, you know, uh, MIT lectures and Andrew Ng's lecture in the public domain about how the simplest of optimization algorithms, the gradient descent, works, right? And slowly dive deep into uh, these optimization algorithms, there are some disadvantages, and how you can solve for those disadvantages in slightly advanced algorithms depending on the use case that you are developing. So there are numerous lectures around these algorithms, and yeah, we should never shy away from trying to listening to these guys talking about these algorithms. in depth, right? And the math behind it, and it's all about knowing that will make us really good data scientists. If we don't know how these algorithms function or optimize and get to a point of accuracy that is satisfactory, it's hard to use them, right? um, all right. Yeah. Can AI be used to understand the behavior of kids under 3 years of age, as they can't express their needs? Um, so I think it's a great AI problem, and it's no different from any other AI problem of pattern recognition of data that doesn't tell you anything. It doesn't express anything. Yeah, if you stare at it, it just doesn't say anything. But when you apply AI to the data collected, the patterns start emerging. So all it requires is the data around, uh, the parameters that you're tracking for a 3 years of age um, person to or a child to get to what you want. But let me caution there, like there is this generalized AI versus whatever data AI that we are currently in. The generalized AI, or AI that can have human intelligence to understand, respond, as we are rapidly evolving there. It's The prediction is it takes a very long time to develop that kind of generalized AI. It's going to I mean, the prediction is at least the later half of this decade, or even more, where we will get some decent success there. But yeah, I mean, I think the question here is around just to understand um, what what the 3-year-old child says, rather than um, behave like a 3-year-old child. That's totally a different problem. All right. Yeah. Thanks, Shivam, that this session was useful. Thanks for your comment there. But yeah, I mean, it's data science is really. I tell my ninth grader, my daughter, that data science and machine learning, no matter what profession you choose, you need to have a basic understanding of data science. It's going to be inevitable. You need to going deeper is good, but it's going to be touch all our lives, and it's already there everywhere. So have fun with it. I think that's all the questions that I had in the coming from the team. So let's. I think we spilled over by five minutes. So can we call it a wrap here? Over to you, Balaji. Hello.
Hello, sir.
Yeah, we are done with the session. Over to you. Yeah.
Okay, sir. Thank you so much, sir. Yeah, we can close, sir.
Yeah. All right. Thank you. Bye bye.